As a biologist, I learned to mentally organize the living world in terms of sequence similarity. There's good reasons for this. For starters, that's how evolution does it. Evolution, without which nothing in biology makes sense, is a process in which DNA sequences start off identical and gradually diverge over time. Because sequence and function move together, this creates a pattern where similar sequences code for similar functions, usually. Sequence-based thinking is also built in to many of the tools that we use to read and write biology. Before you could synthesize DNA, changes had to be introduced one edit at a time. So new functional sequences were never that different from their parent. You might end up with something that was a little better, faster kinetics, better specificity, but not radically new. Or just think about blast searching. When BLAST came out in the 90s, it was such a powerful tool for searching DNA based on sequence similarity, there was never a need to use anything else. BLAST, it spoiled us. It made us soft. If you discovered an unknown DNA sequence and you wanted to know the function, you just blast it to find similar sequences. It's usually safe to assume that the hits would have similar function, and if there were no blast hits, well, that function was probably going to be a mystery forever. The upshot of these historical constraints is that a certain mental model took hold. We envision enzyme space as a cloud of similar sequences. Usually in the center of this cloud is a single enzyme that just happens to have functional data associated with it. You can see this mental model at work in the many biological patents that claim a single amino acid sequence and everything that is 95% similar or some other threshold. The assumption is that the function, the thing that matters, can be well approximated by the sequence, the thing that can be easily edited and searched. Okay, anyway, machine learning blows this up completely. The sequence-based mental model needs to go, at least when it comes to engineering biology with a function in mind. It's structure, not sequence, that determines function. And now that ML-generated structural models are always accessible, structure needs to be the primitive data type around which we organize our biological thinking. Sequence, still important, of course, but secondary. Enzymes with similar sequences can perform different chemistry. Enzymes with different sequences can perform the same chemistry. Scientifically speaking, I know it's not a particularly hot take. Biologists have known for a while that convergent evolution in enzyme active sites is not a rare phenomenon. It's kind of a case of we saw, but we did not see. We all knew that structure mattered, but without the tools to work on structure directly, we just fell into the habit of putting sequence first. What does it mean to organize your mental model of enzyme engineering around structure rather than sequence? I'm struggling to wrap my head around it, just like everybody else. We're gonna need practice. We're gonna need new metaphors. So here's my attempt. Enzyme engineering, it's like shopping. It's like shopping. The old way of enzyme engineering was like shopping for designer clothes. You start with a name brand. The store's well organized, but it offers only a few different styles and sizes. You come out looking like everybody else. The new way is like thrift shopping. Tons of options laying out in piles. Who knows what you might find? Every new DNA sequencing project is like a new box of options to sift through. You should expect to be surprised, and you should expect to come away with something that nobody else has.